Assalamualaikum student. I am Dr. Bilal, Assistant Professor at Department of Chemistry, Quad University of Science and Technology, Cohort. Welcome to course Microwave Spectroscopy. The topic of today's lecture is Introduction to Microwave Spectroscopy. In this lecture, we will cover microwave spectrum, classification of molecule on the basis of rotation, selection rule for microwave spectroscopy. First of all, we will discuss what is the electromagnetic radiation different region. So electromagnetic radiation composed of different frequency radiation. Each region of electromagnetic radiation can cause specific type of transition in the molecule. For example, we have X-ray. This region of electromagnetic radiation cause inner shell electronic transition. Next is the ultraviolet and visible region. The frequency or the radiation of this region can cause electronic excitation. Infrared radiation produce a change in the vibration of the molecule, while the microwave region can cause change in the rotation of the molecules. Now, rotational region, microwave region of electromagnetic radiation have range from 3×10 to 3×12, and they have a longer wavelength as compared to the X-ray, ultraviolet and infrared region. Here we compare the different energy level for the electronic transition, ultraviolet region, vibrational region and the rotation region. So we can easily observe here that the energy gap for the electronic transition is highest, then for vibration is lower, and for rotation is the lowest. And if you compare the energy, electronic transition energy change is highest, then the vibration and the lowest is the rotation energy level. So here vibration energy level we can say present in the ground state of the electronic transition, and if we compare the rotation energy level, their different energy level is available here present in the lowest energy of vibration energy level. Here if we discuss how the rotational spectrum is formed. If you consider electromagnetic radiation of the microwave region is coming and they are interacting with the rotating molecule. If this region, this wavelength radiation have a frequency is matching with the energy gap between the two rotating energy level, then this wavelength radiation will be absorbed by rotating molecule, and they will jump to the higher rotating energy level, and here absorption we will observe in the spectrum. So if we plot the frequency scan on the x-axis and absorption intensity on the y-axis, we will observe such type of volcano graph, and this represent here intensity is lower, then increase, and then highest. So this represent a different energy level, the population of the molecule in different energy level. This we will discuss in detail in coming lecture. So in this slide we will discuss the classification of molecule under the basis of rotation. So first of all, microwave spectroscopy is concerned with the rotating of molecule. Now this rotating of molecule is complex in 3 dimension, and they compose of 3 perpendicular axes, 3 perpendicular direction to the center of gravity. So we can divide this into 3 groups, 3 moment of inertia, IA, IB and IC, because they are rotating in 3 axes of rotation: x-axis, y-axis and z-axis. Now on the basis of rotation, molecule will be classified into linear molecule, in which molecule are linearly arranged, and the atom will be in a straight line. For example, we have molecule of HCl or OCS, so their rotation will be either along bond axis. This value will be very less, and we will consider almost Ia will be equal to 0, while along y axis and along z axis they have some value which will be greater than 0. Next is the symmetric top molecule. Symmetric top molecule example is the methyl chloride, which are tetrahedrally arranged. Their bond around the carbon atom and their moment of inertia is Ib will be equal to Ic, but this Ib, Ic will be not equal to Ia. Ia will be different from Ib and Ic, and Ia will have some value. It will be greater than 0. Now this is further classified. Those molecules in which moment of inertia of Ib, Ic is greater than Ia we will call prolate symmetric top molecule, and example is methyl chloride, while those molecules in which moment of inertia of Ia is greater than Ib and Ic, such molecule we will call oblate symmetric top molecules. Next is the spherical top molecule, in which all the three moments of inertia are similar. Ib, Ia and Ic will be similar. Example is methane molecule. And the last asymmetric top molecule, in which all the three moments of inertia are different. So example is a water molecule and ethylene chloride molecule. Now in this slide we will discuss different terminology used in microwave spectroscopy. First of all, linear velocity. As we know that linear velocity is that distance covered in particular time in particular direction. So molecule having linear velocity, there will be associated with the linear momentum, and their value will be equal to m multiply v, means mass multiply velocity of molecule. Next is the angular velocity. When the molecule is rotating, they have also a specific type of velocity which we will call angular velocity, and their value will be equal to omega. It is equal to E over R. This angular momentum body is associated with the angular momentum. If a molecule is rotating in the anti-clockwise, their direction will be the upper from the page or plane. Next is the moment of inertia. Moment of inertia is actually the measure of the object or resistance to the change in its rotation. When the molecule is rotating, the body will resist to the change in the rotation. This resistance we will call moment of inertia. Now this moment of inertia through center of gravity have specific value of the atom from center of gravity. This distance we will call a radius, and this moment of inertia will be equal to mr square. Now what is the selection rule for rotational spectra? Which molecule will give a rotation spectra, which molecule don't have a rotational spectra? So those molecules which have permanent dipole will absorb the electromagnetic radiation in the microwave region and will give the spectrum in the microwave region. And for example, the permanent dipole is actually the charge present on the atom ion in the molecule and the distance between the two molecules. P is equal to Q dot D. And if electromagnetic radiation comes, so the electric field of this molecule interact with the charge present on these ions in the molecule, and this cause rotation of the molecule, and we will get such type of a spectrum. Now those molecules which do not have permanent dipole will not able to absorb the electromagnetic radiation in the microwave region. Example क्या है, होमोन्यूक्लियर molecule है. O2, H2, Cl2, Br2, etc. molecule. This molecule don't have a permanent dipole. That's why no change in the dipole moment will produced by the electromagnetic radiation in the microwave region. Similarly, linear molecule जो है along x axis, their value is very small moment of inertia, very small change in the dipole moment. Therefore, we ignore this change in the dipole moment, and the spectra of the rotating molecule along x-axis in the linear molecule will be almost equal to 0, and there will be no spectrum developed. Thank you very much. If you have any question, please contact me, and in coming lecture we will discuss origin or molecules.